So from yesterday's lesson, I hope that you figured out how to draw a corresponding scale diagram. Today, we're going to try to figure out the same exact answer mathematically. So how do we approach this problem? Well, here's the interesting thing. Any vector that you take out there, it can be split up into its horizontal and vertical components. And that's the hack in solving these problems. So for example, delta D1 can be broken up as seen on the screen. D2, there's no point breaking it up because it's already facing towards the west. But D3 has a corresponding horizontal component and vertical component. And if you just connect all the reds together from head to tail, you'll get your resultant horizontal component. And if you connect all the blues together and connect them to the head of the red vector, you'll see that you'll form a lovely right triangle down here. And then we can finish off this problem by using the Pythagorean theorem alongside with arctan. So let's get started. Here's the first vector. If it helps, sketch out the vector itself. That way you can get your bearings and your directions straight. In this case over here, we probably want to draw out this triangle by starting off with our vertical component followed by our horizontal. After all, that's what the 20 degrees is describing. So how would we figure out this part over here? Use the memory aid of SOHCAHTOA. Which one will help us out? Excellent. So, as this part over here is opposite of the angle. Alright, we're trying to solve for this component, which is technically delta dx. So we'll isolate for it by multiplying both sides by delta d1, which is the hypotenuse. In fact, interestingly enough, this will be the characteristic setup of how you solve these problems. It will always be the hypotenuse multiplied by a trig function. And we'll use that as a shortcut in the future. But for now, let's just sub in our known values. Our hypotenuse is 50 meters, the angle is at 20 degrees, and our calculator spits out that number there. As for direction, there's two ways of figuring it out. First, if you take a look at your scale diagram or your brief little sketch, you'll see the points towards the right, which represents east. Another way of solving is that if you're trying to add up your horizontal component, look at the vectors posed to you. Which one is a horizontal direction? That's right, east. So those are the two ways of figuring out that this resultant displacement is 17.1 meters towards the east. What about this height now? How tall is this vector? If you guessed using cosine, that's true. Cosine is equal to adjacent over hypotenuse. In your rearranging, you'll multiply both sides by the hypotenuse, so the hypotenuse will be upstairs. As mentioned earlier, this is a characteristic of how you'd always rearrange these equations. So if you can, try memorizing it in its rearranged format, which will always be the hypotenuse times one of the two trig functions, either sine or cosine. Crunch the numbers in your calculator, and hopefully it should be comparable to 50 meters, not as small as 17 meters. As for direction, there's two ways of figuring it out. You'll see that in your sketch it points upwards, and as a component of the vector, only north is described, so it must be north. Let's rinse and repeat for this one over here. Truth be told, you really don't have to do any calculations. I think it's obvious that there's only a delta dx component, but let's just go through some calculations just for kicks. You can imagine this as the world's flattest triangle. Okay, so a super flat triangle. With a super flat triangle, it has an angle of 0 degrees. So hypothetically speaking, how would you calculate this out if you were to spend the extra time in doing that? Well, for the dx component, you'll see that this is beside our hypotenuse. So that's why we're going to use cosine. Crunch the numbers in, and I hope you memorize this by now. Cosine of 0 will always give you 1, as in 100%. After all, when you look at this triangle over here, the side length, or the adjacent side, is 100% the length of the hypotenuse. So that's why it's going to be 30 times 1, or 30 times 100%. Well, let's rinse and repeat for the vertical component. In the world's flattest triangle, how tall is it? As this is the opposite vector, that's why we're going to use sine to solve for this. We sub everything in, and once again, I hope you know the answer to this part. What is the sine of 0 degrees? Try on your calculator. It'll always give you 0. After all, in the world's flattest triangle, the height of it will be 0% of its hypotenuse. I hope that makes sense. So do you have to show these steps formally? No, you don't have to. I'm just showing you that math always works. It's one of the neat things about math and physics. How about try this one out on your own? And we'll zoom in. Not that you have to draw out a sketch, but often when I solve these problems, I'll often just draw some crosshairs so that I have my origin set, and then I know that this is west 50 degrees towards the south. It just gets me set up so that I know my bearings for my adjacent and my hypotenuse, just like in my PowerPoint. There you go, it's all set up. All right. As for the adjacent component, or the delta dx component, it is adjacent to this triangle here, and we're going to use the shortcut now. As I said, the formatting is always the hypotenuse times the trig function. So since the vector we're looking for is adjacent to the hypotenuse, we're going to multiply the hypotenuse by the cosine of 50 degrees. That'll save us at least one step. You don't have to show that original formula anymore. Just cut to the chase. As for direction, I think the diagram shows it obviously, and I think that west also gives it away. As for the vertical component, you can see that it is opposite of 50 degrees, so we're going to multiply the hypotenuse by the sine of 50 degrees. Crunch it through. Either take a look at your givens or look at your sketch, and you'll realize that it's pointing towards the south. Excellent. Now we've taken all three vectors of our problem of the squirrel running around, and we've broken up into its horizontal and vertical components. Next, we're going to add all these components together. Okay. So 17.10 meters east plus 30 meters towards the west plus 51.42 meters towards the west. Well, you can't add east and west together, so we have to do a little bit of number and manipulation. 30 meters west has the same meaning as negative 30 meters towards the east. Excellent. Same as 51.42 meters west. That has the same meaning as negative 51.42 meters towards the east. So now you could do 17.10 minus 30 minus 51.42, which will give us negative 64.32 meters east. Now, if this is your final answer, I mentioned this from the previous unit, don't leave it as a minus sign. All right, now if you don't know what the direction is, then fine, put the minus sign there. But this is negative 64 meters east. If you already know that it's opposite of east, why not just state it as west? All right, so watch out for that. If this is a final answer, never leave your final statement as a negative value if you already know the direction. We'll rinse and repeat for the y dimension as well. We're going to add 46 meters plus negative 61.2 meters, and it'll give us a negative answer, or pointing towards the south. Armed with that knowledge, we can now solve for this hypotenuse right over here. Please don't use c is equal to a squared plus b squared all square rooted. Instead, give it context. Delta dr, without the vector on top, just to save us some time, is equal to this nice and clean formula. Sub everything in, crunch it through, and you'll get to your answer. Lastly, as for that angle, look at the setup over here. This is opposite of the angle, and this is adjacent. So therefore, the theta is equal to tan inverse of opposite over adjacent, or delta dy over delta dx. Sub the values in, and you're almost there. That's the last money right there. Okay, state your final answer. Don't just give me these two values over here, especially since 12 degrees doesn't really tell us much. All right, tell me that it's west 13 degrees towards the south. I believe all the givens were 2 sig fig, and that's why I stated my final answer as 2 sig fig as well. Sound good? Now, this takes a long time to write out, and if you want to do the chart method, by all means. All right, so this is your first time doing these type of things, and go ahead, draw all the stuff out and solve it, and then have a little tally chart at the bottom showing me that you've added it all up and that now you're solving for your resultant displacement and corresponding angle. That's fine. But there is a faster, cleaner way of solving it. In fact, we can show all of our numbers in one PowerPoint screen. So how about we do that? All right, here's another example. Grace the dove goes looking for an olive branch. She first flies 50 meters east 30 degrees north and then flies 20 meters north 60 degrees west. What is her resultant displacement? So after stating out my givens, the next thing I would do is I just draw a tiny little diagram just for my reference of what all this stuff here means. So 50 meters east 30 degrees north represents a vector that looks like that. That way I can quickly piece out what my horizontal component is and what my vertical component is and solve with the appropriate trig function. I'll rinse and repeat with the second vector as well. Okay, so north 60 degrees towards the west, and it'll probably look something like this, 60 degrees. So in this example here, my red vector is opposite and my blue vector is adjacent to my 60 degrees. You see how useful that sketch is? It's not that it's mandatory, but if you need to visualize it, that's probably the best way to do it. And just leave it on the side and don't worry, I'll pretend as if you never wrote that out in the first place. Okay. Oh, I have it animated out. Oh, sweet. There you go. It's all animated out. Okay, so how will we solve this? Using the shortcut method. First, we'll break it down into its horizontal and vertical components, and we probably want to clear off any of those vector boxes by just making an assumption. So we'll just assume that east is positive. Okay, so then what would my delta dx be equal to then? Delta dx will be equal to this component over here, which since it's beside 30 degrees, it will be vector number 1, so delta d1 times the cosine of 30 degrees. You'll see that this vector is pointing the opposite way, so we need to subtract the second vector. Delta d2 of our hypotenuse times, that's opposite of 60, so times the sine of 60 degrees. Make sense? Crunch it through, and you'll get your subtotal for your resultant displacement horizontally. Rinse and repeat in the vertical dimension. Okay, so you'll start off with your assumptions, then delta dy is equal to, in this case over here, this vector here is opposite of 30 degrees, so you multiply the hypotenuse of delta d1 by the sine of 30 degrees. It's pointing upwards, so it's positive. The second vector is also pointing upwards, so we'll add the second vertical component with delta d2, or the hypotenuse, times, and this time around you'll notice that it's beside 60 degrees, so it's cosine of 60 degrees. And the formula would look like that. Hope that all makes sense. And then you'll get to an answer here. Here's a quick tip. Do each one independently. Alright, so after you're done with the horizontal component, take your hand, cover it up. Don't even look at it. Just deal with the vertical one by itself, as if you never solved for the horizontal. This will always be the case. If on one of the components you use cosine, on the other one you'll use sine. And if you use sine on one of them, you'll use cosine on the other one. I'm not asking you to cheat by using this, alright, because a lot of people, by temptation, if they use cosine at the beginning, they'll automatically use sine at the end. I want you to keep them as isolated things so that in case you make a mistake, you can see it right there. Alright, so for example, in the vertical dimension, let's say you did write this down as cosine because you didn't peek and take a look at your x component. Then when you're reviewing through everything before you move forwards, you'll notice that, hey, there's two cosines representing the same vector. Something went wrong, and that's when you have a chance to revisit it. Okay, so that's a good quick tip. But now that we've solved for these two parts over here, it might be helpful to draw a quick sketch of what this represents. Okay, so red vector pointing this way, and a blue vector slightly longer. Now, since it's slightly longer, we know that this theta over here will be greater than 45 degrees. It's just a good way to, mentally prepare for the answer so that you know whether you've answered it correctly or not. Okay, so if you draw out the triangle like this, then you're going to have delta dy over delta dx for your tan inverse formula. Where is it? Right there. Okay. Or if you drew it the other way around, where you start off with the blue vector first, followed by the red vector, then it will be delta dx over delta dy. Doesn't matter to me which one you use. Alright, but you'll crunch through it, and as you can see, you can get to the entire solution in one PowerPoint slide. This is the method I do recommend that you start solving your problems from now on, but if this is your first time working through these, then by all means, do the chart method, and once you get comfortable with it, use these short one-liner way of solving it. It'll save you a lot of time, especially in grade 12. with that said and done, I guess that's about it. I'll leave this last PowerPoint because this just emphasizes when to use y over x or x versus y. In this case over here, I start off with the red vector first, followed by the vertical vector. So in this case over here, my tan inverse will be delta dy over delta dx. Or if I drew the blue vector first, followed by the red vector, well, in this case over here, this is my opposite. So my tan inverse in brackets would be delta dx over delta dy. Pick your poison, and I'll catch you in the next episode.